Hey guys, in this video we're going to be starting 7b.3. Our mastery learning objective is I can write the ratios for sine, cosine, and tangent using the Pythagorean theorem to calculate the missing side. So our first example here says find the sine, cosine, and tangent of A. Now when we are looking at this, we are missing one of our legs, right? We have our hypotenuse, we have our C value, but we do not have our other leg. So thinking back to our Pythagorean theorem, remember, use our Pythagorean theorem, which is a squared plus b squared equaling c squared. So a squared plus b squared equals c squared. Now, we're just trying to figure out what this missing side is. So remember, across from that 90-degree angle was our C. It's also our hypotenuse. And then these two legs are just our missing legs. You could use X and B, it doesn't really matter. We just need to figure out what that missing side is. So our A was going to be 8 squared. You could use B. You could also use our X, doesn't matter. We can leave it as B squared. And then our C squared is going to be 10 squared. So go ahead and we're going to simplify that. I'm going to just simplify this and say that this is just B so we don't get confused later. 8 squared is 64. We do not know what B squared is. And then 10 squared is 100. I want to get my B by itself. So I am going to go ahead and subtract 64 over to the other side. And that's going to give me B squared is equal to 36. To undo squaring something, I take the square root of both sides. And therefore, B is equal to 6. So this is my missing side now. And now I can go ahead and label my sine, cosine, and tangent from angle A because I know all the information of every side of my triangle. So again, this is my given angle. So I'm going to be looking from angle A, and I'm going to label my opposite, adjacent, and hypotenuse. So what's nice is that hypotenuse was our C value, right? Because that's across from the 90. That doesn't matter what angle you're looking for. That is always going to be our hypotenuse. And we're going to label our opposite and our adjacent just so that we can easily write our ratios later. So opposite of A is over here. So my opposite is going to be 6. And adjacent to angle A is 8 over here. So this is going to be my adjacent side. So when I set up my ratios, sine of A, sine is the opposite over the hypotenuse. So opposite is 6. Hypotenuse was 10. And when I simplify 6 over 10, that is going to give me 3 over 5. Next ratio is the cosine. So cosine still of A. Cosine is the adjacent side over the hypotenuse. So our adjacent side was 8. Our hypotenuse is still 10. And 8 over 10 simplifies to 4/5. Next one is the tangent of A. Tangent of A is the opposite over the adjacent. Opposite of A is 6. Adjacent of A is 8. And 6 over 8 simplifies to 3/4. Again, you just plugging these fractions into your calculator and simplifying when possible. So always remember that if you have a missing side, before you try to figure out what those trig ratios are, just go ahead and use your Pythagorean theorem, solve for that missing side, and that's going to help us figure out what each of those ratios simplifies to. All right, our next example here, it's telling us that given the tangent of some angle, so this angle, in case you're unaware, this right here, this means theta, and that's just taking place of an angle we don't know. So it's telling us that the tangent of theta is 5 over 12. Find the sine of theta. Well, there's kind of a couple steps that we need to take in order to solve for what our sine is. So the first thing, step number 1, I'm going to kind of write my steps over here. So step number 1 is we need to draw a right triangle. So draw a right triangle. And then we want to mark one angle as theta. One angle. Ooh. Have to close to the edge there. Sorry. And theta. Right, and theta is our, oh, with that line through it. So first step is we're gonna draw a right triangle. Right triangle. Try to be as nice as possible. This is gonna be my right angle here, and I'm gonna just say that this is my angle theta. So this is gonna be my reference angle. That's the angle that I'm looking for on each one of these steps. Step number 2 says, well, now I am going to, step number 2, I am going to use the given ratio, trig ratio, T-R-I, trig ratio, to find two sides. So the trig ratio that I was given was tangent of theta equaling 5/12. So tangent of theta is equal to 5/12. What helps me is that theta, or tangent is equal to the opposite over the adjacent side, which means my opposite side is 5 and my adjacent side is 12, right? So what we're going to do is label my triangle based off of that. So from my theta, looking at our triangle here, opposite is over here, and my adjacent side is over here. Across from the 90, yes, is our hypotenuse. And now we label the sides that we do have. 5 was my opposite side, so this is going to equal 5. And my adjacent side was equal to 12. Again, that's because they told us it was the tangent. And then we use our SOHCAHTOA to help us out, right? SOHCAHTOA. And this is where we see our tangent is equal to the opposite over the adjacent. All right, so now that we have that labeled, step 3 would be, well, we need to use the Pythagorean theorem to figure out our missing side. So use Pythagorean theorem to find missing side. Ooh. All right, so our missing side, so we're going to set up our a squared plus b squared equaling c squared. So this is going to be, this could be my a, this could be my b, and we know our c is our hypotenuse. So setting this up, I'm going to have a squared plus b squared equals c squared. Our a was 12, so 12 squared plus 5 squared equals our c squared. 12 squared is 144. 5 squared is 25. And c squared we don't know still. 144 plus 25 is 169, still equal to c squared. I have to do the opposite operation here. And therefore, my c, my hypotenuse, is going to equal 13. So this tells me that this whole side is equal to 13. My c and my hypotenuse is 13. Now, step 4, we can finally answer our question here. So here, step 4 would be find the trig ratio. Trig ratio that it is asking for. In our case, it's asking us to solve the sine of theta. So sine of theta, sine is equal to opposite over hypotenuse. Therefore, opposite of my theta was 5. Our hypotenuse, which we just solved for, was 13. 5 over 13 does not simplify, so this is my final answer. Sine of theta is 5 over 13. Okay, so kind of a lot of steps, but everything we've already covered, so it should, now that we wrote all these steps, I'm not going to write them again. You should have them on your note packet, so please reference them if you need them when you need them. So looking at example number 6, it says, given the cosine of theta is 3/5, find the tangent of theta. So remember, one thing to start off with is that we always start off with our little, what we're given, right? Cosine of any angle is the adjacent side over the hypotenuse. But they told us that our cosine was 3/5. All right, so when I draw my triangle here, draw my right triangle, making this my theta again. We know opposite of this angle is here. My hypotenuse is always across from the 90, and that leaves this side to be my adjacent side. So when we go ahead and label this, my 3/5 here, my A is 3, and my hypotenuse is 5. And I have to find what my missing side is over here. So I'm looking for whatever my opposite side is. And that means I have to do my Pythagorean theorem, right? So Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to let this be my a, I'm going to let this be my b, and this is obviously my c. So a squared plus b squared equals c squared. So this is 3 squared plus b squared equals 5 squared. 3 squared is 9 plus b squared equals 25. I want to go ahead and bring that 9 over, so I do the opposite, which is subtracting it. So b squared equals 16. The opposite of squaring something, the inverse, is taking the square root. So therefore, my b is 4. But again, I'm not done, because that was only part of answering my question, because they asked us what the tangent of theta is. So now, tangent of theta is opposite over our adjacent side. So from our theta, opposite now is 4. Our adjacent side that was given to us is 3. And 4 over 3 does not simplify, so therefore that is my final answer. Alright, last example here tells us the given angle for theta is 9 over 41. We want to find the cosine of theta. So again, start off with that same step of, well, sine of theta, of any theta, is opposite over the hypotenuse. They told us that our sine was 9 over 41. So therefore, on my triangle here, this is my theta again. Opposite is over here. My hypotenuse is across from the 90, which leaves this side to be my adjacent side. Substituting in what I know each side is, if my opposite is 9, and my hypotenuse is 41, that leaves me with one leg and our hypotenuse, which is our c value. So we need to use the Pythagorean theorem to figure out what each side is. So this is my a, this is my b, and this is my c. Again, a and b do not matter. You'd get the same answer. That's okay. What's important is that your c is your hypotenuse, and that is isolated on the one side by itself. So our a squared is what we're looking for. We don't know that adjacent side. B, however, is 9, and C is going to be 41 squared. Simplifying this all out, this would be a squared still. 9 squared is 81. And 41 squared is 1,681. I want to move that 81 over, so I'm going to go ahead and subtract 81. And that's going to give me a squared is equal to 1,600. I take the square root of both sides because that is the inverse of squaring, which is going to give me that A is equal to 40. So therefore, this missing side right here is equal to 40. That allows me to go back and answer my final question, which was finding the cosine of theta. So cosine of theta, cosine is adjacent, not opposite. So this is going to be the adjacent over the hypotenuse. Our adjacent side was that missing side right here, which is 40. Again, I'm just circling so you guys see where I'm pulling the numbers. You don't need to circle it on your packet if you're able to see. And then our hypotenuse is 41. And then 40 over 41 does not simplify, and that gives us our final answer. Okay, go ahead and work on activity 7B.3. There's also the AB quiz review, so work on that AB quiz review, and then work, the next step would just be taking that AB quiz. Good luck.